where if I have a parallelogram, you actually probably would have started off, actually, let me do this. You would have started with what was called a quadrilateral. We would have talked about that a lot. Quad meaning four. Okay. So one sort of a quadrilateral is, nothing is congruent, nothing is parallel. There's just kind of a random four-sided figure that all connects. Okay. Another type of a quadrilateral is a parallelogram. So these are kind of what we did yesterday. Parallelograms, opposite sides are parallel, opposite sides are congruent, all the stuff that you did in notes yesterday and in the homework yesterday. And then from there, your little flow chart from a parallelogram could be what we call a rectangle. We dealt with that a little yesterday. Could be also what we would call, if I can try to draw this in good, a parallelogram where all the sides are congruent. My pen is not cooperating right now. Different one. Where all the sides are congruent. So in a rectangle, it satisfies all these properties, but you just have these 90-degree angles. So that's kind of the unique part about a parallelogram that's a rectangle. All our angles are 90. Anybody remember what this was called? A parallelogram and all the sides are congruent to each other. Was it? You could say that. So you could say that. There's a fancier name. So equilateral does mean all the sides are congruent. So we could say this is an equilateral parallelogram. That's fair. That's a correct statement. There's a fancier name for that, though. Starts with an R, spelled weird. Yeah, there you go. Rhombus. So that is a rhombus. It's a parallelogram. So here's our parallelogram. But a rectangle parallelogram. There you go. A rectangle and a rhombus have unique properties in and of itself that a general parallelogram does not. And then when we combine these two guys, the most specific is this guy, where it not only takes on the properties of the rectangle and the parallelogram, all those properties from yesterday and the 90-degree angles, but also the rhombus, where all of these are congruent. This is what we call a good old-fashioned what? A square. So a square is really a rhombus. You could also call a square a rectangle. You could call a square a parallelogram. You could call a square a quadrilateral. It's really all of those things. So it takes on all of those properties. So this flow chart, think about this flow chart as we go through these, because these properties can be a little bit overwhelming. There's a lot of stuff here, but kind of understand how this would relate. If you are a square, it takes on every property of everything above it. Okay. If you are a rhombus, it's going to take on every property of everything above it, along with its own unique properties. All right. So let's jump into these. This is what we did yesterday for notes, what you did yesterday for homework. So we don't need to dive into these too much. We should know these. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And then we got into diagonals a little bit. They're going to bisect each other. Okay, so that's all the stuff that we did yesterday. When we now go to this next item in our flow chart, so I'm going to go to rectangles. So if I go to a rectangle, first and foremost, all the properties that we did yesterday apply, because a rectangle is a parallelogram. So all 5 of the ones we just listed are going to apply still. It has 2 special qualities that a regular parallelogram do not. And that, for the first one, is all of your angles are right angles. So these are 90-degree angles. So that is what makes it a little bit more different, a little more specific than a general parallelogram, the 90-degree angles in the corners. The other thing that makes it different than a regular parallelogram, so if I drew in this parallelogram, just eyeballing it, is there any chance that this length here and this length here are congruent to each other? All right, which one is pretty clearly the longer one, the red one or the black one? What do we think? The black one, right? So in a parallelogram, your diagonals are not congruent. But in a rectangle, what we were telling you is the diagonals are congruent. So whatever this length is here, this length here is going to be identical. And the eye test would kind of verify that as well. So these two things make them a little more specific than just a general parallelogram. Okay. All right. When we go to the other side of a parallelogram, a rhombus. So if we go to the next one, if I have a rhombus is a parallelogram. So that's why number one is saying all the properties from the very first thing are going to apply. And then the big thing is two consecutive sides are congruent by definition. That kind of goes without saying. This really covers all of that. All the sides are congruent in this. So on this one, I would mark that. This side, this side, this side, this side, they are all congruent to each other if it is a rhombus. Here is a now unique property that we want to understand. The diagonals now bisect not just each other. That's still going to be true. They also bisect the angles. So what that means is if I look at this diagonal right here, this angle, that means like if this is a 40-degree angle, this is also a 40-degree angle. The diagonals cut your angles right in half. 5. The diagonals are perpendicular bisectors of each other. From a parallelogram, we know this is the midpoint. So we already know our diagonals bisect each other. If it is a rhombus, they're also perpendicular to each other. So that means this angle right here is a 90-degree angle, as well as every other one of those angles where the diagonals bisect each other. All right. All right. And then last but not least, the diagonals bisect the rhombus into 4 congruent triangles. So what that means is these 4 triangles are the exact same lengths, degree measures. They have the exact same area. They're identical triangles, basically stacked on top of each other to create the overall shape. Okay. That's a rhombus. Now, a square isn't a square all of those things. So a square is going to take on every single property that we've said today. So that's what this is saying. All the properties of a rectangle apply. All the properties of a rhombus apply, as well as a parallelogram. The only thing that is unique, the diagonals form 4 isosceles right triangles. So yeah, these are still going to be 90-degree angles. All that stuff is still true. If there are isosceles right triangles, that just means that this segment, all of these are congruent. So if I look at this triangle here, it's an isosceles triangle because these two sides are congruent to each other. Okay. Okay. Last one, I think there's one more. We're not going to deal with trapezoids. Well, maybe we will. We'll see here. But a kite. So there is a third and final. You don't really do this last year. A kite is a parallelogram. So as best you can, I'm not a very good kite drawer myself. Drawing something that looks like this. Or it's on the paper too, I suppose. The one on the bottom of the paper is much better than the one that I just attempted to draw. Okay. That's a kite. All right. In a kite, it says 2 disjoint pairs of consecutive sides are congruent. So what that means is if we look at the opposite sides, here are opposite sides, just again, the eye test. Do these opposite sides even look like they are congruent? No. What this is saying is basically it's the 2 sets of consecutive sides are congruent. So this side and this side are going to be congruent. This side and that side are going to be congruent. All right. So it's the only one where the opposite sides aren't going to end up being congruent. The diagonals are perpendicular to each other. So that means we have a bunch of 90-degree angles in here. One diagonal is the perpendicular bisector of the other. It would have to be this one here that's getting cut in half. This one here is the one where this is the midpoint of that segment. It's the perpendicular bisector. The diagonals bisect each pair of angles. So again, if this is a 20-degree angle, this would also be a 20-degree angle. It cuts it right in half. And then this says one and only one pair of opposite angles are congruent. And all the other ones that we would have done above, all the opposite angles are congruent. So if we look at this, the angles, opposite angles are congruent. If I look at these guys right here, if this is an overall 40-degree angle, hopefully we would look, this is a bigger angle than this one. But if we look at these two guys, so use tick marks here, that's how we mark in congruent angles. This angle is congruent to this angle, but the other ones are not. All right. All right, now go to the next page. I think we're going to skip the trapezoid for right now. I don't think I gave you a trapezoid in this. Oh, I do. Okay, let's talk about trapezoids because we are going to talk about those here. Says the legs are congruent by definition. Your legs are the parallel sides. So in a trapezoid, there's only one set of parallel sides. Okay, the bases are parallel. Since these are parallel, those are what you would call your bases. Whatever the parallel sides are, those are your bases. So label those as the bases. The non-parallel sides, so notice how this side here and this side here, no chance that those are parallel. Again, just kind of observing it. These are what we call our legs. And property number one is telling you those are congruent. So we'll put little tick marks here indicating that those are going to be congruent. Understand what isosceles meant in a triangle. Then that mean two sides are congruent. It means the same thing here. An isosceles trapezoid means just two sides are congruent, and it's going to be the two legs. All right, the lower base angles are congruent. So here's the lower base. So this angle is congruent to that angle. If we flipped it upside down, then these two angles up here would be congruent. That would then become our base. But basically, the base angles are congruent. That's what this one is saying. And then the diagonals are congruent. So whatever this diagonal is and whatever this diagonal is will be the same. And then the lower base angle, so this guy here and this guy here, these are supplementary to each other. So if this is like 80, this would have to be 100. All right, these guys add up to be 180. All right, so a lot to process here. Now you have those, so you can reference those as we go through these. So go to this first problem. And where do we even begin with all of those there? So it says, find the missing angles in this rhombus. So first and foremost, a rhombus is a parallelogram. 100% what we would have done last night for some of these ideas. So I could have given you this last night, and you should have been able to knock out a number of these angles. So real quick, here's the angle we should be able to get pretty quickly. Find angle 4. All right, what does angle 4 have to be? 35. This is nothing more than a parallelogram, so what we've been doing for a little while now. These two lines here are parallel to each other. This is the transversal cutting through right here. 4 and 35 are alternate interior angles. Those have to be congruent. All right. So from there, we know this is a 35-degree angle. Now, after that, you probably want to go back to the rhombus section and kind of look at some of the properties that deal with some angles. So if we go back to our rhombus idea, so you have all these to reference. Clear this up so I can highlight the one that we're going to use. Obviously, we want the ones that talk about angles. So any that talk about the sides don't really do us a whole lot of good. Pens are not wanting to cooperate today. All right, so as we kind of look through these, all the properties of parallelogram apply. And then it says two consecutive sides are congruent. That's a side, doesn't do us any good with angles. Same here, all the sides are congruent. This one is nice. The diagonals bisect your angles within the rhombus. So think about what that means. If the diagonals are bisecting the angles of that rhombus, go back and fill in what that now allows us to write down. Okay, can anybody give me, there should be two angles now that we can write down just based on that idea. Jeez, come on. There we go. All right, anybody know what those would be? Mondo? We're going to get to that one. So I'll come back to you for that then. So if I give you this idea, so and that would allow us to kind of go through. But if I told you that your diagonals are bisecting the angles, if I use that idea, we have two diagonals. This is a diagonal. This is a diagonal. Understanding that, what we have marked, that should give us two angles right away. Armando? 1 and 5 are 35 degrees. Good. Angle 1 and 5 must also be 35 degrees. Why is this not working today? 35 degrees. Because this diagonal should be cutting that big angle right in half. So basically means that's a 70-degree angle. The diagonal cut it right in half so that it's 35. Okay? So as you kind of go through these, we got to look at these properties. That's the first one that you could apply that deals with an angle. Now, Armando then brought up this next property in the rhombus. So the next property in the rhombus is this guy. The diagonals are perpendicular bisectors of each other. So similar. Take that property there. That should allow us to fill in a few more angles. So if those diagonals are perpendicular bisectors of each other, we now have a way to fill in some more of those angles. Okay, anybody know what two angles now that allows us to fill in? Of the numbered angles anyway. So if this diagonal here and this diagonal here, we've known for the last 24 hours that these bisect each other. In a rhombus, not only do they bisect each other, they're also perpendicular to each other. So if these are perpendicular to each other, what do all of these angles right here have to be? Good. These here all need to be 90 degrees. Okay. Now, it's up to you. There's really two different ways you could go. My way that I think most of you will understand the quickest, don't we now have a triangle right here where we know two of the three sides? Or two of the three angles. So we can pretty quickly get that missing angle, 180 minus these two. However, let me show you kind of a different way, because that's ways we could have certainly have done. Think about it this way now too. If this is a overall 70-degree angle, aren't these two angles supplementary to each other, these big angles? So if that's 70, didn't this have to be 110? And doesn't this cut that right in half? It bisects that angle. So that 110-degree angle getting cut in half means these are both 55. But again, it's the same thing you would have got if you would have gotten two of the three angles and you did the whole triangles adding up to be 180 angle idea, also would have given you 55 for those. All right. And then the same exact thing down here. These are alternate interior angles. We're going to get 55 all around. Okay. All right. Next one. I'll give you a few minutes on this one. See how many of these angles you could figure out. It's a rectangle. So anything above a rectangle, which is any parallelogram idea, as well as those things in the rectangle are going to apply. And again, multiple ways to kind of work your way around this here. You did do that. That's good. You can expect something. Let's see if this checks. Okay. It is. So what does this overall work out? That's 30. What does this guy have? Right. So that's at 60. And then that allows you to get these correctly known if I say, oh, it's 30, it's 30, you're good. That's 60. Tells us the first half. That's 30. Okay, we're good. We're good through this, all right. All right, Jada, what'd you do first, Jada? Good. So all of these angles, these big angles she understood were right angles. So she did 90 minus 30 because down here we knew this was a 30-degree angle. So if I did 90 minus 30 to get 60, angle 1 has to be a 60-degree angle. Okay. If we know those two angles, what other two angles do we then know, Jada? Good. So these are opposite of each other. They're cut by that transversal. So the alternate interior angles need to be congruent. So that's 30, and then this is 60. Okay. All right. So now the next thing, whether we fully understood it or not, what do you have next? Give me something else you know there, Jada. Okay, so she said they're all the same. Here's how we know they are all the same, other than kind of just eyeballing it. In a rectangle, the theorem we want to kind of understand is that in a rectangle, where is it? I'll show you right there. In a rectangle, all of your diagonals are congruent. So if we threw numbers down, which I won't, but if I threw numbers into these are all the same lengths. So if this is 20, then this is 20. From yesterday's stuff, don't diagonals also bisect each other? So doesn't that mean, like, let's say this full thing was 20, this full thing is 20. Doesn't that mean these are all now 10? Now, the number isn't important. We don't know what the number is, but what it does tell us is all of these segments here have to be congruent to each other. And then the reason we know those angles, other than it does kind of just look right, isn't this here from our last module, isn't this an isosceles triangle? Here are my two congruent sides. In an isosceles triangle, aren't opposite angles congruent to each other? So if this angle was 30, then this angle is going to be 30. All right. And then once we know that, this is 60. These are alternate interior angles, so that's got to be 60. This has to be 30, so they're alternate interior with this. And then if I now clean this up a little bit. And then now the one that everybody remembers, once I know 2 of the 3 angles within these triangles, you can get the third. So if that's 60, 60, you do 180 minus those 2 60s. This has to be 60. Vertical angles are congruent, so that then means angle 9 must also be 60, or you could do the triangle over here. These should all add up to be 180 as well. The missing angle, angle 8, you now have a couple of options. You could, again, treat this as a big triangle. They add up to be 180. Or you could just understand it's a straight line. So the 60 and the 8 have to add up to be 180. Either way, angle 8 would have been 120 degrees. All right. A number of people got it, at least on the east side of the room as I was walking around. A lot of people were getting those. Okay. All right. Last one real quick. It says solve for PS. So that is this side right here. That's what we're looking for. And RS, if this is an isosceles trapezoid. Then I tell you that A to T is 13. So I'm actually giving you this one as 13. And then we're talking about the other diagonal. Okay. So as we look at that one, go to your isosceles trapezoid rules and kind of reference these. If we look at this right here to kind of understand how we just want to reference some of these, how we can use this, the diagonals are congruent to each other. They have the same exact lengths. So if we go back to the one that you were looking at, I gave you the red diagonal, but isn't the red diagonal going to be the same as this other diagonal? So if the red diagonal is 13, then this black diagonal must also be 13. So those 2 guys, the x plus the 5 and the 2x minus a 1, must add up to be that 13. So while giving you the other one, it's really giving you the one that we're working with because they're congruent to each other. All right. And then you just solve that. I'm going to trust we can solve this. Okay, pretty simple little equation there. When you do solve that, we then plug in to find PS and RS. And again, this is what we've been doing for a while. So you just take those, substitute those in, get each individual length. All right, and then that's the PS and the RS. All right. All right. Here's some of these to try. Okay, try that. See how this goes. There's a little bit of, there's a parallelogram, rectangle, rhombus, and a square, and it's going to kind of put all of these properties, keep them all straight. There's a lot to process. Okay. Again, if you have any questions, we can talk about them tomorrow.
Mr. Finn,
Yeah.
can I go pick up an off-campus pass?
Yeah, that's fine. Bring your stuff. Oh, yeah. I recorded too, right?